Hi, my name is Nikki Seward, and this is a series on water flow in the Sacramento-San Joaquin Delta. And I'm a layperson from the Delta. I have a business in the Delta and land in the Delta. And my purpose is to help others who might not necessarily know about water flow in the Delta in California to understand in a simplified way, but using the actual state documents and state records of water flow, what is the truth about water flow in and out of the Delta. First of all, you need to know where's the Delta. A lot of people don't realize that we do have a Delta in California because the media and schools are really not talking about the Delta anymore. So I want you to understand where's the Delta. Sorry, I'm being very basic for some of you who know exactly where it is, but just for those, particularly a school teacher that's going to do a program, the Delta is between Sacramento and San Francisco's over down here. That's the San Francisco Bay. The Delta leads out into the San Francisco Bay. There are two rivers, main rivers of the Delta. There's the Sacramento River that flows down this way, and the San Joaquin River comes from the south and flows over to through the Delta. This series looks at entirely only Sacramento River flow and the question about how much water does or does not flow from the I Street Bridge in Sacramento through the north and west Delta and out into the Sassoon Bay. Note that all the graphics and maps used are online. If you get this PDF over at deltarevision.com on the water flow pages, you can enlarge this PDF and you can see exactly where. Like here, for example, is where I got this. This is the water plan. California Department of Water Resources has most of the documents online, and then there's other resources that where you can get a lot of the documents. They're also gathered at deltarevision.com, which is a gathering of documents by Delta landowners to go over these issues. Now I'm going to go back to slide 1 actually. The purpose of this particular 10-minute video is to talk about answer a couple questions. We're only going to try and answer number 1. We're going to try and answer through the series how much fresh water from the Sacramento River flows into the Delta on average in an average water year. And then we're going to ask and answer how much fresh water continues to flow on the Sacramento River past the Rio Vista Bridge and into the Soon Marsh San Francisco Bay in an average water year. So that's what we want to answer. And you'll understand why we want to answer that as we go through this series. Okay, so you'll see that here is a map of the Delta, and then I added a simple formula. X minus Y equals Z. And you'll see this one, this map came from the water boards, and this is a water rights map, and you can see where exactly we got that. You'll see that there is a website called BayDeltaConservationPlan.com. There's a lot of documents there. And this one actually I screen printed. That should be an M there, monitoring stations of the Delta. But I use this one because I wanted you to see X is up by Sacramento, the city of Sacramento, this area. Y is flowing through the Delta. Now Y in this particular series, Y is how much is exported in the past and what they're planning in the future. That's what we're going to look at. So X is the water we start out with, Y is how much exported, and Z is how much left to go into the bay historically and what is being proposed. Here's the formula, X minus Y equals Z. Now what you're going to find is these 3 different videos. We're just looking at X in this one, and then we'll work on the rest of that as we go through. Now, why is this important? Well, the state of California is going through this huge plan where they want to divert even more water from the Sacramento River, and the river just doesn't have that much water. The state came up with a very complicated net delta outflow index to, and we're not going to really go over this right now, but I wanted you to know that the water flow is counted very closely. We're going to look at the next one, and but over the last about 10 years, there's been a huge inconsistency in how water flow is calculated. They're using computer modeling, but what goes into the computer modeling affects what comes out, and that's just how it is with computer or mathematical formulas. And so this is going to be very important for people in the Delta in San Francisco Bay. I also want to point out a slide. This is from, again, California. This is the water boards, and it was a presentation, and it said, inappropriate inconsistency can result in inequitable treatment, no common understanding of key water quality and water rights goals, and difficulty in achieving a meaningful evaluation of outcomes. Well, what you'll find is since 2004, and maybe just a little bit earlier, there has been inappropriate inconsistency in how water flow and water exports are being reported. It depends on which agency you're going to, but they're state agencies, but they definitely change around and create inconsistencies intentionally. Okay, so here we want to answer, how much fresh water from the Sacramento River flows into the Delta on an average water year? What is X? Well, the answer is it depends on which agency determined the average. An average water year flow from the Sacramento River through the Delta can range from 17,000 acre feet to 21,000 acre feet. Excuse me, depends on who's counting. That is 4,000 acre feet average per year. So what's 1,000 acre feet? And these numbers, actually, I'm going to round these, and the 17,000 acre feet is 17 million acre feet. But most of the historical reports of the past use TAF, 1,000 acre feet. So that is why I use these documents. I'm going to refer to 17,000 acre feet, or TAF, as 17 million acre feet. Well, for a layperson, how much water is that? That is enough water, based on other reports, for 1 to 2 households per acre foot. So that's enough for more than 8 million residents. That's their water for the whole year. So the difference between the documents saying how much water flows on the Sacramento River right at the I Street Bridge or right in Sacramento is the difference is 8 million households water for a year. That is a huge difference. And so we have to figure out, okay, what really is what's the average water year, so we can figure out what average is appropriate to divert from the Delta, because they want to divert more, they meaning some state contractors. So I'm going to go on. So I'm going to use the million acre feet instead of the 1,000. So for teachers, and maybe I'll make this, there we go, make that a little more viewable. To simplify this presentation, because anybody other than water engineers probably has trouble understanding what's 1,000 acre feet, pull out at least 17 glasses of water, and actually I'd go to 21 glasses of water and put them on your desk, and the kids are going to be utilizing this water, if you want to, as we go through the presentation and we talk about water exports. You're going to dump out that water, and then you're going to see exactly how much is left to flow on the Sacramento River. So this is a simplified way of looking at it, but it helps. There will be a video showing the classroom doing that. Anyway, so we all documents, and when you go through this series at deltarevision.com, go to the water flow pages, and you'll see, hundreds of documents talking about how much water on average is on the Sacramento River. And prior to 2003 and before, the average was 17 million acre feet. And thereafter, through changes in how it's calculated or years it's calculated, they've been using a different number. And I'll show why that's important later on. Okay, so who cares if there's a difference of 4 million acre feet of Sacramento River flow in an annual year? Anyone in Northern California, the Bay, certainly anyone in North Central and West Delta who farms or has residents or businesses or wells in the Delta, because if additional water is taken when there isn't enough left in the Delta, that is going to leave us with less water quality, or if water quality at all. In the San Francisco Bay, that usually gets flushed out in winter with fresh water from the Sacramento River, it won't happen anymore. So that should be a concern to Bay Area people. It can affect the whole Northern California aquifer if the new plans go through. So this X is very important before you can even answer Y and Z. So let's go on. We're just answering X right here. So here I'm going to enlarge this. You need to know that the state and actually federal government very closely monitor how much water flows through the Delta. There are all kinds of computer models. There's monitoring stations all over the place. This is just one of the computer models. Maybe I'll make that a little bit bigger. And by the way, if you're on YouTube and you can, and you're looking at this on a very little screen, you can click over to the right. YouTube has this little function where you can click and make it show on your whole computer screen, and I'd suggest you do that. You can also just get the PDF at this deltarevision.com on the water issues and water flow pages and look at the PDF on the side too. This graphic here, this is part of a larger chart, and it shows how the water flows and where the monitoring stations are. And this is for flood flows. There's other graphics. I'm going to go over to this one. Is these particular ones, CalSim and CalSim 2, were used for the current California Department of Water Resources documents, the Bay Delta Conservation Plan, the Delta Plan. They also use DSM-2, the hydrology, computer modeling. There's the ICU. There are the UNET. There's just so many different computer programs calculating water flow. It's pretty impressive, but CalSim 2, these particular models are used to look at flow through the Delta cross channel and other areas of the Delta, and so that's why I focused on these particular ones and how these numbers are the basis for these particular computer programs. So here is just a graphic. This is from the Bay Delta Office, the Delta Atlas 2003 waterways, but it covered a whole bunch of other issues. And you'll see in the past that there's a consistency in some of the graphics and also consistency on what it said. And before 2003, before, we were told that on average water year, there's 17,000 acre feet or 17 million acre feet of water flow on the Sacramento River. And you'll notice that the water flow is separated out from the yellow bypass. And the annual average inflows to the Delta included the San Joaquin River, that's over here, and you'll see the big difference between San Joaquin River and Sacramento River. But that was the considered the average annual inflow, the number that we would start with for X. However, then starting in 2004, really, this document was produced. This one, I believe, is more in 2006. And you can enlarge these and see where I got these. Maybe I'll do that just so you can see it. So you can see one of them, where this one came from. That was a 2000. This one is a 2009 one, and it talks about average water years. I'm going to go back down so we can see that better. And what we saw was the 2009 water report. It said an average water year has 18 million acre feet on the Sacramento River. Well, what changed was that the state started using for calcium and all that. They said the year 2000 is an average water year. But then other documents from the state said 2000 is an above normal water year. But calcium and all the computer modeling for the 2012 Bay Delta Conservation Plan used the numbers from the year 2000, at least what they said in the original calcium, and then calcium 2 was built upon that. And so this was actually an above normal. You see the other documents, and it says that was an above normal water year, but the 2009 state documents say it was an average water year. So there's a question, is it above normal, is it not? In any case, what it shows is the state uses just a shorter series of water years instead of the whole 100 years or more of counting water flow in Sacramento River, and they look at a wet series of years and say, okay, well, this is the average. Well, why do they want to inflate the number of how much water is flowing on Sacramento River? Well, they want to inflate on paper how much is flowing so they can inflate how much they can export. Kind of simple concept. Okay, so again, this is the 2000 water year, and we're going to look at that. Here's a little bit of that net delta outflow index. If 2000 was really an above normal year, even though they were saying it was a normal year, that's that inflation right away. And now you'll see in 2012 that instead of using that what's a normal water year, they realizing, looking back, that they had made that little mistake in calcium. Now what we see is they don't even talk about normal years. They'll go below normal year, above normal year, but what's the normal year? They used to, if you look at all past documents, they looked at normal year. Now they're trying to avoid that issue. So if you look at a series of documents, there's a whole bunch, you'll see that it's documented what I'm talking about. So let's go on. Calcium and their annual report in 2000 on which calcium is based uses for a average water year, it uses 18 million feet. That really is an inflation. But let's go on. So what happens when we see the 2008 State of the Bay Delta Science Report? There's different maps. So this is also a map produced in 2008 by a different agency, and it says that for the Sacramento River there is 18 million acre feet, and yet on this State of the Bay Delta Science Report it says 21 million acre feet, or 21,000 acre feet. So say 21 million acre feet. So where'd this number come from? Well, and again, when you see the small print, I'm going to make this larger so you can see that one again. See if that helps at all. Well, I'll make this one even bigger. Well, so this is sciencecalwater.ca.gov, and this is 2008, and in that report it says the year 2000 is an average. And again, all the other reports say, or most of the other reports say, 2000 was an above average acre foot or water flow year. So it totals the Sacramento River total. What that does is it takes the Yolo bypass flow. I can move over here so you can see this in a little bit more. They took the Sacramento River flow that was inflated number, take the Yolo bypass flow, and I'm not sure where that number even came from, but if you go to past documents you can see where it came from, and that's where they come with this new number. Well, why do they want to represent that water that flows down this way is counted as flowing? So they're saying, sorry, Yolo bypass, they're saying goes up and down this way. It doesn't do that. It physically, Yolo bypass water flows, it comes through down this way and only flows on Sacramento River right in here. Well, why do they want to do this? Well, the net delta outflow index looks at how much water could be exported down to the export pumps, which are in this area. So by inflating the number that starts here, they can inflate the number that ends up here. And but the result is that there's much less water flow in the North Delta. So that is one of the biggest problems for North Delta people. Let's go on. Okay, so we're still looking at more documents, and now we're looking at the Delta Plan. This is the 5th staff draft, and what do we see? They're referring to other sources, and now the Delta Plan goes and looks at a wider range. The Delta Plan says there's as much as 29 million acre feet on the Sacramento River, and then they split out the Yolo bypass, and notice that they've switched from the TAF number to they're using million acre feet math, and then they say the minimum is 10 million acre feet on the Sacramento River, and they split back out the Yolo bypass. So they go from a wet year to a dry year, and actually past records show that a dry year could be as low as 6 million acre feet. We'll look at that again. So all of this to say we're still trying to look at X, how much water flows on average on the Sacramento River through the Delta. Okay, so this looks at, this is another one of the documents, and historical flows on the Sacramento River. Well, and this one uses cubic feet per second. So now we're finding instead of TAF, we're going to have to look at cubic feet per second and convert it over to acre feet, which we'll do later on. I'll show you how that's done. And in the meantime, you look at, well, where'd they get their averages? Well, they looked at a different time period. They looked at wetter years and created this inflated average, which really, if you want to look at an average over time, you really need to look at it a longer time span if you want the truth. So here's another document, and I'm going to enlarge this one so it makes it easier for you to see this. This is a historical operations study. This is CalSim again. This is the that computer modeling, and it talks about the basis for all the information. And I know the link is on this document. I always put the links on the document, so it is at deltarevision.com. You can see that whole report, or you can go to water.ca.gov and put in that name, and you'll be able to find that report. And so it talks about the historical natural flow on the Sacramento River and the Trinity River imports, but historical natural flow on the Sacramento River Valley. And they're using all the valley, and this one is good because, once again, it talks about, this is what the computer modeling is based on, and it is 17 million acre feet. They go back to the TAF, 17 million acre feet, and this one goes through a span of years, and we can see this average line in here, and it is 17 million acre feet. not the higher number that you will see in the Delta plan. This other one is another map that shows, it separates out yellow bypass and shows the minimum flows, and you can look at that if you want. I'm trying to just find the average right now. Here's another one. I'm going to enlarge this one too. This is a organization called PPIC that gets funding from nonprofits and organizations that want to take more water out of the Delta. But I thought it was interesting slide or graphics. They said here it is unimpaired annual flow on the Sacramento River water, and you see where they got their references, and they use Department of Water Resources, and sometimes it's kind of hard to find the exact numbers, but it shows a really variability here on stream flow. This is on the Sacramento River, and it goes through the Delta, and what you see here's 15 million acre feet here, right? So 15 to 20, and again, we looked at, the state was saying now it's 21, and here's 15. This line here, right here, is the average that used to be used right along here, this number 7, and we do have all the references. Literally, there's hundreds of documents that estimate and refer to the 17 million acre feet, or 17,000 acre feet, and this should be the average use, and that's what CalSim was based on, but the more recent documents want to use in the 20 to 21 range, which just isn't the truth. It doesn't have that much water flow. So let's go on. So here's another chart. This one is by PPIC, and you can again read this. If I'm going too fast on this, you can go back to these slides and read the slides, and it'll talk about more. The PPIC report talked about global warming. They had a different one, and they talked about spring and summer runoff has been declining as a share of the annual runoff on California's major rivers. So this is more of a California major rivers, and the importance of this particular slide or graphic is it shows there's a decline in runoff, not an increase as DWR wants you to believe in 2012, but there's a decline if you look over time, and you can get the actual numbers from the state. You gotta go looking around, but from their past reports, look at reports before 2003, or actually before 1998, I'd say. They might not look as fancy as the current computer modeling, but you'll actually get the real numbers instead of fabricated numbers. So look at anything before 1998 if you want to get actual historical numbers. So I just wanted to show you that it's declining, not increasing. So what we've been trying to do for the last 10 or 15 minutes is say, what's X? So X might be between 17 million acre feet and 21 million acre feet. And you'll see in the next series that I hope you'll go on to that this becomes very important, because over the last 10 years, there have been a series of regional projects that are all designed to divert additional water from the Sacramento River. They have been built. Some of them are still being built, like the Stockton siphons are being built right now. And Freeport Pump is already built, and it will export 185 million gallons a day. Notice that report didn't talk about TAF. That's where we start seeing the inconsistencies over the last since 2003. Different EIR, EIS processes use different versions. So you use CFS, cubic feet per second, use TAF, use MAF, use AF, million gallons a day. And so to be able to understand what each of these reports are saying is going to be diverted from the Sacramento River water, it becomes necessary for you to answer y, in the formula, you've got to start doing some conversions. So this might be a calculator time because it's rather big numbers. So we've tried to answer x. X is somewhere between 17 million acre feet and 21 million acre feet. And this is x is just simply Sacramento River flow. So x depends on who's counting, what average year they use, what water year, what series of water years. And why should you care if you're not in the Delta? Well, everyone who eats California vegetables should care, because it's going to affect your vegetables. If you get produce from the Central Valley, if you drink wine from Napa Valley, if more water is diverted from the Sacramento River than actually is there, it will reduce the aquifers of the Delta in Northern California and the Delta's prime farmland. That will affect quality of all the produce in Northern California eventually. So that is another series I hope you will look at. But in the meantime, if there isn't the water to divert, why are we allowing it? So let's go on. Just a reminder about the inappropriate inconsistencies. You will see in the next series how inconsistent all those regional projects were in counting water flow. So please go to the next graphic, and if you have any questions or all the documents that relate to what I went through, or their links, you can find at this website. Then please go to graphics 2.